Hi, this is Algebra 1, Module 3, Lesson 6, Interpreting Functions. We are given this graph, f of x, to answer the following questions. Unless otherwise specified, restrict the domain of the function to what you see in the graph below. So we're assuming what we see is what is there, and that's it. Approximations are appropriate answers. So some of these, we don't have great grid marks, so we'll just figure it out as close as we can. So first of all, we're just going to go through and answer all these different questions. So what is f of 2? So that means when my x value is 2, so that's right over here. Oh, you know what? I'm going to delete that. So right over here, when x is 2, I want to go up on my graph, and my point is about 6. So I'm going to put in here 6. All right. For what values, if any, does f of x equal 3? Well, that means I want to go to where my answer is 3. So my y value is 3. And we have one spot right over here. And that is at 0. X equals 0, y equals 3. What is our x-intercept? So where is it crossing the x-axis? Right over here. And that looks like it's at -2. So let's put -2. Put up a little. Oh, maybe not. All right. Scoot it over. Doesn't want to listen to me. Okay, next, what is the domain of f of x? Well, if we look over here, it starts over here at -4, and it goes over here to 6. So domain is going to be brackets, because it's including them, -4, comma, 6, end bracket. You know what? I need to go up here and make this a proper point. X-intercept is -2, 0. And let me widen my box so that that's proper on that one. All right, what is the interval? On what intervals is f of x greater than 0? So when are my y's greater than 0? Well, it looks like over here at my x-intercept, -2, all the way up to the right, we go as far as 6. That's the interval that my y's are positive. So I'm going to put -2, comma, 6 in brackets. All right. On what intervals is f of x increasing? Well, it's only increasing going from left to right. So we can put the whole domain on there. So all the way from -4 to +6, it's increasing all the way across there. What intervals is it decreasing? Well, we don't really have any because we just said it was all increasing, so that would be none. For what values, if any, is f of x greater than 3? So when are my y's greater than 3? So if I look over here, well, y equals 3 right here. So basically at 0, when x equals 0, that is when my y's get bigger than 3. So I'm going to go from 0, and they continue all the way to 6. 6. All right, so that's our first set of questions. Let's analyze this graph here. 9. All right, so for 9, consider the linear graph f of t, so that's this guy right here, on the nonlinear graph and the nonlinear graph of g of t. So we've got an exponential, well, not exponential, nonlinear. We have a linear graph and a nonlinear. We haven't talked about what kind g of t is. To answer the questions 9 through 14, approximations are appropriate answers. So again, we can't see exactly where some of these cross, but we'll do our best. So where is f of t equal to g of t? Well, they cross right here and they cross over here. So we have 2 points at which they are equal to each other. And those points are approximately -2, comma, -1, and 3, comma 4. Both of those points is where they are pretty much equal to each other. Number 10, where is f of t greater than g of t? Well, f of t, actually between those 2 points, that's the only spots that they're actually greater than g of t, right? Because otherwise the g of t is higher. So our interval where f of t is greater starts at -2 and it goes all the way over to +3. What is f of 0 plus g of 0? Well, to figure that one out, f of 0, let's see, f of 0 would be about -1. So we have a -1 on this one. And then g of 0 is -5. So if I add -1, oh, sorry, +1, and -5, I'm going to get, I'm going to go ahead and show my work over here. So f of 0 was +1, and I'm going to add to it the -5, which g of 0 is, and that would equal -4. And a different color since we're starting to get crowded. All right, next. Same idea, only this time we're going to do -1, f of -1, and g of -1. So let's go ahead and come on over here. F of -1, so f -1 right here. So that's 0. And g of -1 is about -4. So I'm going to come back over here and type in my, as we said, f of -1 was 0. And we're going to add to that g of 0, or g of -1, which was -4, and that would equal -4. So those actually equal the same thing when we add them together. So which is greater, f of 0 or g of -3? Well, let's see. F of 0, so when f is 0, we have an answer of -1. It's -1 or g of -3. So if I go to -3, 1, 2, -3, oh, well, that's definitely going to be bigger. That's closer to, wait, 1, 2, I'm off a little bit. Here we go. That's a better one. About 4 or 4. So g of -3 would be our better one, our greater. Graph f of t plus g of t from -1 to 3. Okay, well, let's see here. We said -1 when we added them together. So if we do, let's go ahead and just do a little table over here on the side. Just going to write one out here. So we have -1, 0, 1, 2, and then 3. Okay, well, we said the -1 plus the -1 was -4. And then when we did 0 plus 0 was also -4. So f of 1 is 2 plus g of 1 is -4. So that one's going to be a -2. Why this is not writing on here. If I go to the 2's, I have about 3 plus -1. So that would be a positive 2, right? Positive 2. And if I go from the 3's, oh, they were both 4, right? That's where it was one of the points. Yep, that was one of the points where they were equal. So 4 plus 4 is 8. All right, so to graph this, let me get a different color since I've used this one quite a bit. Let's do green. So to graph this, I need to have -1 at -4. I need to have 0 at -4, 1 at -2, and 2 at 2, and 3 at 8. So my graph of this guy is going to kind of be on the inside of this one, just a little bit skinnier than what our g of t is on there. All right, answered all the questions there. Let's look at the next one. The following table of values represents two continuous functions, so they're continuous, f of x and g of x. Use the table to answer the following questions. What is g of -3? So if I go over to -3 and I go to g, what I get is, I can, come on, click on here. Doesn't want to, there we go. -3, and that's not working for me. So I get right here with -5. So why it's not letting me do my touch screen. All right, so -5 is my answer when I plug in -3 for my x. For what values is f of x equals 0? Well, f of x is right here, so I want my answer to be 0. Well, if I come down here, notice that f of x equals 0 both at 1 and at 2. So I'm going to go ahead and put that over here. When x equals 1 and x equals 2, or when I have my y's f of x is equaling 0. For what values does f of x seem to be increasing? Well, if I look over here, 44, 30, that's going down. Oh, but once I hit that double 0, we start going back up again. So the values where it seems to be increasing is about somewhere between 1 and 2, right? So we're going to say 1.5 all the way up to 6. And I'm going to include, seems to be increasing. Actually, if that's the bottom of my thing, I don't want to have the bracket. So 1.5 all the way up to 6. My x's get up to 6. Okay, on what interval is g of x greater than f of x? So now I need to compare these across. So it's not bigger, it's not bigger, it's not bigger. Here it's starting to get bigger. So when x equals 0, and we are staying bigger the whole way. So the interval when g of x is bigger than f of x is from 0 all the way up to 6. Which function is changing faster in the interval -5 to -1? Why? All right, so here we go, -5 to -1. So I'm only looking in these top ones. Which one seems to be changing faster? Well, this one's going from 44 all the way down to 6, whereas this one's going from -13 to 3. So f of x actually has the bigger change. Let's go ahead and start typing this. F of x is changing faster because it changes by over, let's say just over 30, where g of x is only changing by, how much is that, 13, -13 to 3 by 16. So it's almost twice as, it's definitely twice as fast because 44 minus 6 is 38. So it's changing by 38. We can go ahead and make that more exact. By 38, where g of x is only changing by 16. So it's f of x is changing twice as fast as g of x. All right, almost done. Use the following relationships to answer the questions below. So, which of the above relations are functions? Well, would this have only one answer if I plug in an x? Yeah. This one have only one answer? Yeah. This one, well, if I put in 1, the answer is 8. If I put in 3, the answer is 8. That's the only answer I can get. So, oh, if I put in 4, I can have any y value, can I? So, let's look at the last one. Yep, that's only every number I put in, I'm going to get one answer out. So, looks like x equals 4 is the only one. Oh, is the only non-function. And that's because our y, it's a line that is vertical, so every y matches it. I'm not going to type all that. You guys can put that on there. So it's the only non-function because the y, if x is 4, then all the points are 4 comma 6, 4 comma 3, 4 comma negative 5. There's multiple y answers for that x value. All right, f of 2, g of 2, and h of 2. So if I plug in a 2 for this x, I have 2 times 3, that's 6. 6 minus 2 is 4. So I'm going to put on here f of 2 equals 4. Okay, let's look at the next one. G of 2 equals what? Well, g of 2, if I put a 2 in here, doesn't really matter. The answer is going to be 8. All right, that's easy. H of 2 equals, let's go over to h. If I put a 2 into here, so 2 to the second power would be 4. There we go. All right, next one. Change colors since we're kind of getting crowded. Write the equation for g of x plus h of x. Okay, so g of x is 8. So I'm going to put 8 plus, what's h of x? H of x is 2 to the x, so I'm going to put plus 2 to the x, and that equals y on here since we don't really have another answer. Okay, so I just put the 2 together. Now I've got my answer. All right, where is g of x greater than h of x? Well, let's see here. G of x is 8. Okay, so we know that that's no matter what, it's going to be 8. So at what point does this get higher than 8? Well, 2 to the first is 2. 2 to the second is 4. 2 to the third is 8. Well, that's when they're equal. So anything bigger than 3 would make this one get larger. So I'm going to go ahead and put in here when x is greater than 3. Now, if it's equal to 3, they're the same. So this one, notice it says when is it greater than that one. So we have to say when it's greater than 3. Where is f of x increasing? 3x minus 2. Well, if you look at the slope, this is linear. So we know it's a straight line. So it's either always increasing or it's always decreasing. And if we look at our slope, the slope is a positive slope. So that means f of x is always increasing. So it is always increasing. All right, which of the above functions has the fastest growth rate? Well, if we're looking at the rates or the ratios on here, we know that exponential is going to go faster than a linear. And these are just straight lines, so they're not going to count. That's a linear. That's a linear. H of x is the only exponential. So we would put h of x equals 2 to the x. All right, so these next ones, I'm not going to sit here and do all the different ones on here, but I am going to do one, the last one kind of as an example to show you what are some things with here. So yeah, maybe I'll do 26. Let's do 26 together just so you get the idea. I'm going to open up a Jamboard here so we can, does not want to work for me. All right. So in making this one, it says this function has the following features. So we are supposed to come up with a graph that does some of these things. So f of 2 is positive, f of negative 2 is 0, f of x is always increasing and has a domain of all real numbers. So let's go ahead and just start a graph on here so we can see what we've got. So, and I'll go ahead and do it in black. All right, so we're going to see if this is going to let me draw again. Oh, good. That's not good. Okay, so I'm going to have just each of these little marks be 1. 1, 2, 3, 4, 5, 6, 7, 8, 9. We'll just go this far on here. I am going to do a little bit of negative since we said we had a negative 2 in there. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 10. Okay. 5. All right, so let's go back to our criteria. F of 2 is positive. So I'm just going to write that over here. It's a positive. F of negative 2 equals 0. Well, I can go ahead and plot that one on here. So F of negative 2 is 0. Let's just put him right on there already. And is always increasing. So always increasing. And it's all real numbers for a domain. So we can use any number on here. So this is the only point I have to have on here. So that's the only point everyone should have is f of negative 2 is 0. And so if it's always increasing and it's all real numbers and f of 2 has to be positive, I just know I have to be above the line once I get over to, above the x-axis once I get over here. So I can just go like this, put arrows on both ends, and I have made it always increasing and a domain of all real numbers. So that's one way you can make these up on here. All right, let's do 27. So for this one, I'll make my graph. And again, we're just going to assume everything's a 1 right now. I'll put in labels as I need to. So 27, this function has the following features. F of 3 is greater than f of 6. F of 1 equals 0. F of 2 equals 4. F of x is increasing from negative 5 to 3 and has a domain from negative 5 to 10. All right, so there's a lot of pieces in here. I have a separate sheet, so I'm going to write down some of these notes on my Jamboard. So let's put 27 on here. So it said f of 3 is greater than f of 6, and f of 1 equals 0, f of 2 equals 4, and I have to have increasing from negative 5 to 3. Those are inside. Oh, 3 is an open parentheses. And then a domain is negative 5 to 10, inclusive. All right, so I know I have to have a point at negative 5 somewhere, so I'm going to go ahead and mark that. 1, 2, 3, 4, 5. I know I need a mark at 10. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I have to go that distance. F of 2 is 4. So let's go ahead and do that. F of 2 is 1, 2, 3, 4. F of 1 is 0. F of 1 is 0. Okay, so those 2 points I have to have. We're increasing from -5 to 3. -5 to 3. So all the way from here. So let's say we go like this. And I have to include -5 when I'm doing my piece here. But 3 is the top of something because it's open. And my whole thing, oh, and -3 has to be, or f of 3 has to be greater than f of 6. So I have to be going downhill to get to 10. So let's see if it makes all the criteria. F of 3 is greater than f of 6. Yep, it is. F of 1 is 0. F of 2 is 4. It is increasing from -5 all the way up to 3. And my domain is -5 to 10. So see how we can break all those down and have our features on here. Let's do 28. Go ahead and do these so you can kind of see the difference on them. All right. So this function has the following features. F of x has a constant rate of change. F of 5 is 0. Okay, so this is a pretty basic one. So constant rate and f of 5 equals 0. So I can keep this one pretty basic. It doesn't say it has to be an increasing rate. It doesn't say it has to be a decreasing rate. 1, 2, 3, 4, 5. So all I really have to do is f of 5 is 0, and I have to make a line. So I'm going to make this one decreasing this time. And there we go. For the last one, create your own conditions, have at least 3, and then create examples where the solution can be a different graph. I actually went ahead and did this one ahead of time. So my criteria that I came up with for this is I had f of 4, let me make this bigger, f of 4 equals 3. The domain is from -3 to 10, and it decreases from, do interval notation, -2 to 5. So these are the criteria that I came up with, and I have 2 different examples of how that could look. So right here, I have f of 4 equals 3. So notice how both my orange and my green graph cross through f4, 3. And then my domain is from -3 to 10. So both my graphs go from -3 to 10. But it has to decrease from -2 to 5. And so this one I did a curve going down from -2 to 5. This one I did a straight line going from -2 to 5 and did it more of a zigzaggy. So notice how they both fit all 3 of my criteria, but they do look different. Well, that's it for this one. Thank you for joining us, and we'll see you again next time. Bye.